Here in our second lesson on compound interest, we'll do an application of the compound interest formula shown here in the images that you included in the completion of assignment 1 there in video 1. Now once again, the compound interest formula is a way to calculate the future value of a particular initially invested amount of money. And what it does is that it takes the simple interest formula and calculates it over and over and over again, but it gets compounded because you keep adding the previously earned interest into the principal amount. That will become clearer as we move through the lessons, and we have some other Google Sheet applications that we'll do. But for this lesson, we just want to get familiar with the idea of compounding periods, and how we can do the calculations using Google Sheets and putting in the algebraic formulas, and then taking a look at the difference between compounding the values 1 time, 2, 4, 12, or 365 times. If we do this formula with the amount of money every single day, how much difference will it make on how much is earned over a period of time? We are going to practice the calculations as those given here in this example. And so we'll work on a principal amount of $100 at 5% for 10 years, and that's the simple interest formula there. And then we'll take a look at the difference as we compound that over different compounding periods. So new to this is we're going to have to do a little bit more. We're going to have to do a little bit more of order of operations control using our parentheses, and we also need to learn how to include an exponent, and we also need to learn how to use Google Sheets to include an exponent within our calculation. Let's go ahead and start with an annual compounding period. We'll start with the equal sign, as we always do. The principal amount is here, $100. We need to multiply that times 1 plus r divided by n. So we need to control that order of operations with a parenthesis. 1 plus, now when we get to the interest rate divided by the number of compounding periods, that division needs to occur before any of the other calculations. So we need to control that with a set of parentheses. R is our interest rate, 5%, must be entered as a decimal, 0.05. Divided by the number of compounding periods. Because we are doing this annually, that's going to be 1 time, 1. Enclose that operation in a parenthesis. And also note that the entire operation needs to be enclosed in a parenthesis. So we have this right-facing parenthesis here. We need to put one more over here to enclose the entire operation. So 1 plus, and then 0.05 divided by 1, and then the entire calculation completed there. The last part of it here is this exponent of n times t. So in order to raise the entire calculation to a power, we need to use the caret, which is the symbol upward facing arrow located above the number 6. So use your shift key, insert that caret. We also need to enclose that calculation of n times t within a parenthesis. And so that is going to be, once again, n is, in this case, 1, number of times compounded per year. Time is 10 years. So times 10. And enclose that. So our calculation should come out to $162.89. And there it is. Now, if your value looks something like this, we just need to reduce those decimal places, which will force the 9 to round up the 8 to a 9. So we have $162.89. Let's do one more, and then you can do the rest on your own, biannually. That would be 2 times. So we are going to have to change the variable n to a 2. Let's practice the calculation again. Equal sign. Once again, the principal is 100 times 1 plus, and we do our division of r divided by n, 0.05 divided by n. In this case, n is 2. and enclose that in parentheses, enclose the entire expression, raise it to a power, and do that calculation of n, which in this case now is 2 times 10 years. Now, when we enter this, our value should be similar, but just a little bit more. The more you compound it, it does increase the amount of interest accumulated, but not that much. But it does make a difference. And that's what we're exploring here in this video. And we'll reduce that, those decimal places, and there it is. So you can see it is a little bit more, about $1 more. So for the remainder of this video, go ahead and compound, use the same formula, do it quarterly, which is 4 times per year, monthly, 12 times per year, and the last one, daily at 365 times. So you're going to be changing n to 365. And then take a look at the values and see how different they are. And when finished, those of you in the class have me take a look at it. And those of you at home can send me a copy of your compound interest worksheet here for video 2. We want to make sure that you understand this, and if there's any issues, do ask me as we move forward here in the world of compound interest.